Good afternoon, everybody. My name is Eric Alarcon,
My name is Idris Nadir.
My name is Ben.
My name is Faith.
and this is our environmental proposal, the reverse vending machine. Just a little bit more about ourselves. My name is Eric Alarcon again. I'm an electrical engineering major. I'm a third year, and I'm also a student in Professor Shah's Engineering 100W course.
My name is Idris Nadir. I'm a civil engineering major, and I'm also a third year student at San Jose State University, and I'm an engineering 100W student.
I'm Faith, and I'm a third year software engineering student and also an engineering 100W student.
My name is Benzu, and I'm an engineering technology major, and I'm also an engineering 100W student.
So our collective group thesis statement is basically that the reverse vending machines are part of a bigger, more cumulative solution to reducing our carbon footprint. This is demonstrated through our extensive research and planning surrounding the overall project design, the cost-benefit analysis, the audience, and emphasizing the need for this project. So I was in charge of the project design component of this project. And the project design component is actually a very vital factor in the project success and execution because we take into account factors like the demographic for which the machine is intended for, the accessibility level to the users, as well as the logistics and engineering that goes on behind the scenes that basically make the solution a reality. So for the demographic, we take into consideration the factors like the hustle and bustle of city goers, the metropolitan lifestyle, as well as the heavier foot traffic that the machine will be exposed to. So as far as the hustle and bustle, people are on the go. So they need a quick and easy way to dispose of their trash instead of inappropriately just throwing it away somewhere else, not recycling it. And this machine will be exposed to the metropolitan demographic, which is always very densely populated. This means that there will be more foot traffic surrounding the machine, and this equates to more recycling being done and less waste being inappropriately disposed of in our community. But in order to ensure that the reverse vending machine is taking advantage of this heavy foot traffic, we need to ensure easy access to it. And this is where the user friendliness is key. The user friendliness aspect takes into account the time and space of the users. This is why we implemented an easy as 1, 2, 3, three-step process to use the machine. And this in turn will cause more recycling to be done. So in today's day and age with the hustle and bustle of city life, not everyone has the time or the space to collect trash in their backyards and wait until it piles up to only then take it to a recycling facility. That's why with our easy three-step process, it'll make it fast and easy for people to recycle their materials and just get going with their day. This in turn will allow for more recycling to be done because it does save money. So especially with this concept of the getting paid instantly, that is a good incentive for people to make money while saving the environment. Now, for the engineering, the inner workings part of this, that entails the engineering and logistics. This is a component that makes the project a reality. So our reverse vending machine is going to feature an easy to use touchscreen where the user is going to make the majority of their interactions with the machine. So first the user is going to insert the bottle. Then when they insert it, they're going to choose whether it's like a bottle or a can, etc. Then the machine will check to see if it is CACRV eligible for recycling here in California. And if it is, it will then weigh the material. Then the material will ingest the bottle into the belly of the machine and compress it inside to save space, allowing for more recycling to be done. Now the compression for the waste inside of the machine will be a super powerful hydraulic press, similar to that of a baler. Those unfamiliar with a baler, what a baler is, it's widely used in factories and warehouses, et cetera, used to compress cardboard boxes. They're extremely powerful machines. And by compressing it, we save space, allowing for more recycling to be done. Now, like I said earlier, the weight of the material will dictate the payout amount. So this is the final step. So the user selects their payout type, and they could choose cold hard cash, to which the machine will dispense it for them, or they can use their Clipper card to load money onto there, and they could withdraw it later like a debit card, or they could just plainly use it. They can continue using it like a Clipper card is used for public transit, etc. All in all, it is a win-win situation with the reverse vending machines, because the public will then be incentivized to save our environment as a whole.
So I'm in charge of the cost benefit analysis portion of the proposal. So the reverse vending machine proposal is designed to be city funded, so it is paid completely by taxpayer money. A cost benefit analysis is an important component of the overall proposal to city officials. The cost benefit analysis is divided into four components: the cost benefit ratio, the return on investment, the internal rate of return, and the payback period. And overall, all four metrics show that this proposal is both environmentally and financially beneficial. The cost-benefit ratio component of the cost-benefit analysis concludes that the proposal produced a net benefit. Cost-benefit ratio measures the relationship between cost and benefit. For this proposal, the cost is coming from the investment from the city, which is taxpayers' money, and the benefit is measured both monetarily and environmentally. The cost of a single reverse vending machine unit ranges anywhere from $10,000 to $25,000. To put the scale of the environmental problem into perspective, as of 2017, 9% of the 9 billion tons of plastic ever produced was recycled. But this leads to phenomena like ocean microplastic contamination of our oceans. And yeah, so in terms of energy saved from using recycled materials, using recycled aluminum rather than raw materials when manufacturing aluminum products saves 95% of the energy. So this energy this 95% of energy that's saved is money that's also saved. So the return on investment portion of the cost benefit analysis shows that the proposal produces a net profit. So profit is measured in this proposal both directly and indirectly. Direct profit is money made from the recycled goods that are collected and sold off, and the indirect payment is made by the energy saved when manufacturing with those recycled goods. So to put it into perspective, a single can will be recycled for roughly 10 cents, and a reverse vending machine unit can collect anywhere to around 1,000 cans per week. So this leads to, with the math on it, leads to around $100 a week. Annually, it will generate around $5,200. This leads to around 5 years of money making to pay off initial investment costs, and 2 years of pure profit, because the machine is meant to run around 7 years. The internal rate of return portion of the cost benefit analysis shows that the proposal is expected to increase profit annually. The internal rate of return measures the annual growth of the investment. So a unit can generate around $5,200 annually for approximately 7 years. The market is also growing. The market is expected to grow from $343.6 million to $685.1 million by the end of 2025. Tomra Systems, which is the leading manufacturer of reverse vending machines, owns 70% of the market shares. Tomra Systems has increased revenue by 9% as of 2019 to around $984 million, with a net profit of $90 million. Currently, they operate exclusively in Europe, but with a greater demand in America, they can move to America as well. So the payback portion of the cost benefit analysis shows that investment costs will be paid back. So a unit will generate roughly $5,200 annually, and an initial investment cost for a single unit is around $25,000 at the higher side. So around 5 years, prices will be paid off, and there'll be time for profit as well. And in terms of money saved from energy saved, Manufacturing using the recycled aluminum uses 95% less energy than when using raw materials. That's also money saved.
I will be talking about the audience of our project. In order to reduce carbon footprint, the implementation of reverse vending machines should be proposed to leaders such as San Jose city officials, sports organizations, and school teams. So reverse vending machines should be proposed to San Jose city officials. By researching the social factors that affect recycling, I found that positive recycling intentions are improved because of the influence of others in places with high visibility behavior. High visibility behavior is basically actions that are influenced by other people. So places with high visibility behavior would be shopping malls, parks, or any place where communities publicly gather. San Jose city officials can help reduce the overall public's carbon footprint by implementing reverse vending machines in these types of locations. Other social factors that can make recycling more convenient are short distances, strategic locations, easy accessibility, and availability. San Jose city officials can implement reverse vending machines where it's easy for people to recycle. For example, convenience stores, bus stops, and train stations. Also, lowering the opportunity costs of recycling for people can increase recycling rates. The incentives provided from reverse vending machines lowers the opportunity cost for people, which will encourage them to recycle more. Proposing reverse vending machines to sports organizations will lower the carbon footprint of athletes and sports audiences. Large-scale sport events leave off a huge environmental footprint. The number of participants and energy required to host sport events translate into a significant amount of products consumed by athletes and sport fans. The food, beverages, and containers that they consume significantly contribute to their carbon footprint. In professional sporting leagues such as NFL, MLB, NBA, and NHL, over 130 million fans that have attended generated around 120 million pounds of CO2. Sports organizations should implement recycling vending machines in gyms and arenas to lower their carbon footprint. Sport organizations also have a really high influence on the recycling behaviors of their fans. In the graph on the right, it shows the average recycling attitudes of fans based on the sports organization's environmental credibility and the fans' level of fan identification. The graph basically shows that the higher the level of fan identification is, the more environmental influence the sport organization has. So sports organizations have a great amount of power when influencing their fans to recycle. That being said, implementing reverse vending machines will encourage their fans to recycle more and reduce their carbon footprint. Reverse vending machines should also be proposed to school deans to reduce the carbon footprint of students and teachers. The school's commitment to sustainability is an important factor when it comes to recycling. When people on campus believe that deans and office staff are committed to office greening, sustainable practices become a norm. School leaders have a really high influence on students when it comes to recycling, mostly because when they become involved in recycling practices and technology, students will become more engaged in recycling. They will also feel like they're contributing to the school community. From a study on recycling rates of different building conditions at a university, the table on the right shows the mean weekly number of plastic bottles placed in recycling and trash bins. It shows that when recycling bins were moved to classrooms, the number of plastic bottles placed in recycling bins increased, and the number of plastic bottles placed in trash bins decreased. This shows that placing reverse vending machines in classrooms can improve the separation of recycled materials and garbage. So school deans can encourage students and teachers to lower their carbon footprint by implementing reverse vending machines in school campuses.
And I'll be focused on the need for the project. So our goal is to reduce non-like plastics, because that will help to slow down carbon footprint, to better the ecosystem and human health. So plastic is the most common material used worldly, and plastics actually produce 15% of total carbon footprint in the world. And each year, there's no slowdown of plastic use. When the plastic are not recycled properly, it will end up in the streets. When rains, it washes into the ocean and kills marine life. Recycling is a better option to reduce plastic waste, because oftentimes the non-recycled plastics are being burned, and that release more carbon footprint and release to the environment, cause human health. People around the world have different types of lifestyles, and some of them might not have the right education of why plastic is harmful for the environment, and find out where and why. And it helps for us to target them and possibly to use our recycle vending machine. If people in the world properly use recycling, and the carbon footprint will reduce by 25% by the year of 2050. And currently, recycling rate is only at 18%, which is very low. And if this continues, the goal of to stop climate change will be hard. With that being said, recycling vending machine can help reduce carbon footprint, and it's easy to use. Everybody can be the solution to prevent climate change in the future.
All in all, as a group, we believe that reverse vending machines are essential in our day-to-day lives, especially today, because they will really actually help reduce our carbon footprint. And we've demonstrated this by showing through the project design, it is feasible and it could be made into reality. We have shown through the cost benefit analysis that it's an effective investment. And also through the audience and need for the project, we have demonstrated that by making it easily accessible in metropolitan areas in our target locations, we can come one step closer to saving our environment as a whole. Here is a breakdown just of our project timeline. Here we showed the beginning stages. Starting at 1, we showed the beginning stages of our project, and we showed basically the assignments that led us up to where we are now, to the final presentation, as well as the correlating dates that kept us on track for the successful completion of this assignment, our Gantt chart. And here are our references for the reference figures. Thank you very much for watching our presentation.